In this lesson, we'll talk about what GD&T is and why it matters. Our goal is simple: to clarify design intent, to secure function, to gain flexibility in manufacturing, and to make sure all teams speak the same language. So why do we need such a language? Because when drawings are misunderstood, assembly becomes difficult, quality fluctuates, and cost increases. Coordinate dimensions and notes only work up to a point. As the part becomes more complex, differences in interpretation, gray areas, and conflicting expectations grow. GD&T comes into play exactly at this point. What is GD&T? GD&T is a language that expresses acceptable deviations in part geometry using symbols and rules. This language makes design intent visible. What do we want? How much deviation do we allow? Relative to which reference? All of this becomes clear. The rules are defined in standards such as ASME 14.5 and ISO 1101. So this is not just internal company jargon, it's a universal means of communication. So what is the core aim of GD&T? Three things: form, fit, and function. We control the form. Is it flat, cylindrical, round, smooth? We protect the fit. Can parts be interchanged with each other? We secure the function. Does the product work in the real world as intended? How do we read this language? GD&T communicates through feature control frames, symbols, basic dimensions, and datum references. A basic dimension represents a theoretical target. The allowed deviation around it is given by the geometric tolerance symbol. Datums are references that represent the real constraints in assembly. When used together, they describe in a single line which feature, how much deviation, and relative to which references we are controlling. Why is GD&T important? Let's summarize it in 5 points. Clear communication. When design, manufacturing, quality, supply chain, and the customer look at a drawing, they all understand the same thing. Uncertainty is reduced, discussions are shorter, and decisions are faster. Functional assurance. What you define on the drawing is what actually happens in assembly and in the field. Where circular fit is needed, you define a circular tolerance zone. Where surface integrity is critical, you use a surface profile control. Functional risks are brought under control from the very beginning. Interchangeability and scalability. Different suppliers produce to the same rule set. Parts can replace each other. As the supply network grows, consistency is not lost. Manufacturing flexibility. GD&T defines the result, not the method. Toolpath, fixture, process sequence. All of these can be flexible as long as function is preserved. The operator and process engineer are free to choose the best way to achieve the target. Cost and lead time management. Instead of unnecessarily tight tolerances, you specify only as tight as needed. Scrap, rework, and repeated measurement loops decrease. Cost per part and overall lead time go down. Let's compare a mini example. A drawing defined with GD&T versus one without. Imagine two drawings side by side. On the left, the holes are defined using plus-minus coordinate tolerances. On the right, they are defined with GD&T symbols, basic dimensions, and explicit datum references. In the plus-minus approach, the tolerance zone often behaves like a square. As you move toward the corners, a larger diagonal error can accidentally be accepted. In assembly, some bolts go in easily, while others get tight or misaligned in certain directions. In GD&T, the allowed variation is defined by a geometrically correct boundary. Basic dimensions define the theoretical target. Datums are clear. The rule is the same for everyone. The result: consistent behavior, fair decisions, and predictable assembly. In which situations does GD&T make a real difference? Rotating parts. Topics like axis alignment, runout, concentricity. Large assemblies, distant hole patterns, reference management on large components. Castings, forgings, sheet metal, controlling form and surface together. Sealing surfaces. A surface profile control can cover form, location, and orientation all at once. Why is datum selection critical? Because a datum must represent the actual surface that contacts and constrains the part in assembly. A randomly chosen surface might look stable in inspection, but can cause surprises during assembly. The correct datum order seats the part in the same way, aligns it in the same way, and locks it in the same way every time. This keeps design intent consistent throughout design, manufacturing, and quality. What is the impact of GD&T on design? It puts design intent at the center of the language. First you define the function, then you distribute tolerances according to that function. You avoid unnecessary constraints and protect what is truly critical. Impact on manufacturing. Freedom and focus. Within the framework that GD&T provides, the process engineer selects the most efficient method. For example, by using a profile tolerance, you can control a surface with a single symbol instead of a cluster of notes. Operators don't get lost in complex annotations. Impact on quality. Fair and repeatable accept/reject decisions. Because the rules are clear, decisions stop depending on the individual. Measurement and evaluation are reported in a logic that is consistent with the datum structure. Data becomes meaningful for root cause analysis. Impact on cost. GD&T breaks the tighter tolerance equals higher cost cycle. You define only the limits that the function truly requires. This positively affects everything from tool life to cycle time, from scrap to rework. What are common mistakes when applying GD&T? Adding plus-minus tolerances to basic dimensions. Basic dimensions are theoretical. The allowance comes from the geometric symbol. Choosing datums that are not functional. Referencing surfaces that never actually contact anything in the real assembly. Leaving the datum reference frame incomplete. Writing rules without defining the order and relationships between datums. Mixing up the purpose of symbols. For example, confusing profile, which can control form, orientation, and sometimes location, with position. Or mixing up runout with simple orientation controls. Going to extremes. Being either overly detailed or overly simple. The drawing either becomes unreadable or insufficient. So where should an organization start? Common vocabulary. Make sure the team agrees on what each symbol means. Datum strategy. Define datums in a way that reflects real assembly constraints. Critical characteristic list. Mark the features that govern product function. Drawing template. Standardized dimension layout, note structure, and revision rules. Supplier alignment. Include GD&T expectations clearly in contracts and quality plans. Measurement plan alignment. Even without going into full detail, ensure that the inspection plan reflects the same rules as the drawing. Feedback loop. Use data from the shop floor and from the field to refine and improve the rules. What is the place of GD&T in the digital workflow? Today, some companies use model-based definition, MBD/PMI. Symbols embedded in the CAD model flow directly into manufacturing and inspection software. This reduces information loss during handovers and keeps revisions in sync. Digital traceability increases, and both speed and consistency improve. A quick look at the symbol families. Form, flatness, straightness, circularity, cylindricity. Orientation, parallelism, perpendicularity, angularity. Location, position, symmetry and related relationships. Profile, line profile, surface profile, highly versatile controls. Runout, controls for surface and total runout in rotating systems. Each of these solves a different problem in a short, precise way. Let's correct a common misconception. GD&T is not extra work. On the contrary, it is a clarification tool that reduces unnecessary work. It defines the job correctly from the start and reduces the need for fixing things later. To summarize, GD&T makes design intent visible and measurable. It secures function and interchangeability. It gives flexibility to manufacturing and a common language to the organization. It makes cost and lead time more manageable. And most importantly, it ensures consistency throughout the entire product life cycle. Today, we focused on the why behind GD&T. In the next lessons, we'll look at the map of the symbols that make up this language. Which symbol solves which problem, and when should it be used? We'll take a quick tour. Thank you for watching. If you found the content valuable, don't forget to like the video. Subscribe so you don't miss the upcoming lessons.